Okay, today what we're going to do is we're going to begin our look at our last topic. We're going to be beginning our discussion of what are called matrices. A matrix is simply a way of writing equations in a format that allows you to solve several equations all at one time, assuming that they have a common solution. Now you can also use matrices to rewrite equations in just a neater form so that you'll be able to do some things with them. So what's going to happen is you're going to leave out all the variables and just use the coefficients or the numbers. So we're going to first start to talk about what a matrix looks like. And to do that, the best way to show it is to actually write out some equations, and then we'll write these in matrix form so that you can see an actual matrix. So here are just two equations, and again, we know that they're equations because they have equal symbols. These particular equations have x and y in them. You'll see that here's the equals and what it equals, the numbers that it equals there on that end. So you just have basic equations where the variables are on one side, the numbers are all on the other side. And remember that these are not number terms, those are the coefficients of the variables. So they're over there with the variables, and you need to leave them there. Alright, so let's write this as a matrix. The first thing is that the matrix is always going to be enclosed in brackets. Now, brackets are those types of parentheses that are square. Okay? So, you're going to have square, parentheses, either side. And that tells you that the thing you're working with is a matrix. If you have a bunch of things contained within those brackets. And then, all we're going to do is we're simply going to only use the numbers. Now, I say the numbers, but if you drop a sign, then you're in big trouble. So remember, the sign is a part of a number. So let's do this top equation first. We have a 3, we have a 5, and we have a 10. Now the bottom equation, we have a 2, we have a -3, and a 12. Now, notice we didn't do any math. All we did was rewrite it only using the coefficients. Now there's part of this that we're missing here. We need to make sure that this equal symbol is represented. And the way we do that is we use where the equal sign or the equal symbol, we're going to use a vertical line. And that just tells you that that's where the equal symbol would be. Okay? Now, not all matrices are going to have them, because you're going to see that we're going to be adding some matrices together, and they're not going to have that vertical line because they're not complete equations. They're just expressions. You can also use matrices with expressions, but they're most frequently used as equations. So if it has the equal symbol in the original, then you need that vertical line in your matrix to determine that equal symbol. Okay? There's also a naming convention for these. So, for example, if I only have one, then we generally name it capital A. Okay? So they're usually named with capital letters. And it doesn't matter what letter you use. It's just a way of saying that this is a matrix. This is matrix A versus matrix B or C or D or whatever. Again, doesn't matter. It's just like sets. Remember, we named sets using capital letters. Just makes it easy to tell you what matrix is what. Okay? Couple of things that you need to remember as well, and maybe you remember this from your studies of working with, I don't know what you would be working with when you would use these, but we have things that are called rows, and rows simply go across. So this is a row, okay? And since it's the top row, it's row 1. You'll see that come into play later. I'm giving you a lot more information than you need right now, but you're gonna see it all comes into play. So this would make this one the second row, so it would be row 2. Okay? Now, so remember, rows always go across. All right? Now, there are also things going up and down, and if you remember, those are called columns. Columns go up and down. This particular matrix has 1, 2, 3 columns, right? Now remember, this line separates it from what it's equal to, so the variables. We're going to talk about that in just a minute. I'm going to rewrite another one that doesn't have the equals symbol, but I wanted you to see one that has the whole bit right off. Okay? So enclosed in brackets, only use the numbers. If you put the variables in these, it's going to make such a mess, you're not going to be able to straighten it out. The equal symbol is always represented by a vertical line, and they're always named using capital letters. You'll also notice, I hope, that when you look at this, there's your x. Whoa, I'm making circles. Never mind. Let's pick something different for that. Sorry. There's your x term, there's your y term, and then what it equals. Down here, there's your x term, and there's your y term. So these things are in what's called descending order. Okay? X's, then your y's, etc. Remember, they go in alphabetical order, descending or alphabetical order. Okay? So don't. So that's another really, really important part of a matrix. Okay? Well, when you have matrices, we can actually do mathematics with them. Just like with any other numbers, we can do some mathematics with them. So first, let's look at a matrix that doesn't have. So let's say we have 3x plus 4y, and then we have negative 2x minus 3y. Okay? So I can write this in matrix form. Notice that if I want to make it as a matrix, just close it in parentheses, the brackets, right? Special kind of parentheses. And then I just put in the numbers. Now notice here, there is no vertical line because what I started with were not two equations. What I started with were two expressions. Remember, the difference between an equation and an expression is the addition or the inclusion of the equal symbol. So these are expressions, but expressions can still be written in matrix form. And if you'll look, this one has 2 rows, right? Row 1, row 2. Remember, rows are the things going across. And it also has 2 columns. Right? Do you see that? 2 things going up and down. Okay. So, if it's got 2 rows and 2 columns, this is called a 2 by 2 matrix. And notice that the number of rows and columns is determined by the number of variables in it. So this is 2 rows, and there's an x and a y, so that gives you 2 columns. Okay? You can have all different kinds of sizes of matrices. So say, for example, that I have 2x, 3x, 4x. I can still write that as a matrix. 2, 3, 4. Okay? So it's still a matrix, and it has 3 rows. But it only has, right, if you look at this, there's row 1. Notice this notation I'm using, row 2, row 3. But it only has 1 column going up and down. So this is a 3 by 1 matrix. The row always comes first, then the number of columns comes second. Okay? These are called the dimensions. The dimensions of a matrix. And the dimensions of a matrix can be anything. It depends on how many rows and how many columns you have. Typically, 2 by 2, 3 by 3 are the most common, but again here, we see a 3 by 1. You can have a 1 by 3. You can have any size. Okay? Now, knowing things about the dimensions are important when you start working with the operations of with these. And remember, anytime anyone says the word operation, they mean add, subtract, multiply, divide, right? So let's talk about the first operation we're going to be doing here, and that is we're going to talk about adding matrices. You can take two matrices and add them together, but you can only do that if they are the same dimension. Because if they're the same dimension, that means your x's and your y's and your z's or whatever, all the variables are in the same place. And remember that if they're in this, if you have things that have the same variable, you can add them together easily. So if they have the same dimension, then everything's in the same order, in the same place, so you'll be able to add them easily. Okay? So they have to have the same dimension. And then to combine them, you're simply going to add the corresponding elements. So all the x's will be added to the other x's, etc. Now you're not going to know where those are though, right? You're just going to have something that looks like this, right? Plus, now I'm adding this up and down, usually will not be written like that. So let's say we have something like this. I want to add these two together. Well, first of all, this one is a 2 by 2, and this one is a 2 by 2. Therefore, I know they can be added. Okay? Make sure you check the dimensions first, because if this one, say, didn't have this, then those two couldn't be added together. So make sure that you know the dimensions can work. And I'm using different numbers there, but it doesn't make the slightest bit of difference. Well, this column, remember, that's where all your x's live. This column is where all your y's live. Well, if it's x's and y's up there, it's going to be the same here. All right? So I can combine basically like terms. So adding the elements, or in other words, the like terms. And I can tell they're like terms because they hold the same position in the matrix, right? When we put them, we make sure that they're always in descending order, and that's how they are always set up, okay? And the third thing you need to always remember is the answer is also a matrix. Don't forget to rewrite it as the answer is a matrix. Now, if you can add them, that means you can also subtract them. But remember to watch the signs when you subtract. Okay? So make sure you're really watching those signs. Because if you subtract a negative number, remember that really becomes adding. Okay, minus a minus becomes a positive. So if you're going to do this, and if you're going to put it in your calculator or whatever, make sure you use that change sign button or use the sign key to make sure that you're putting the right signs in, and make sure that you subtract it, right? So minus a minus again becomes a positive. So be very, very careful about your signs when you're working with these. Okay? So let's go to the homework and look at the very first problem. Now, the way they write this, I really don't like it because they've scrambled things for you a little bit here. I've just told you that they need to be x's and y's and all of that in the right spots. But they're just trying to prove a point here. So you notice that your y's and x's and w's and things are all everywhere else. What they're doing is, what would this number be? And they're calling that number w. What would this be? And they're calling that x. That doesn't mean it corresponds to the variable x or y. I don't like it, but we're stuck with it, so just kind of deal with it. And you're going to have to deal with this particular part of the book. But just remember that we're going to take our operation is addition, right? So that means we're going to take this matrix and add it to this matrix. In order to do that, first of all, we need to know, do they have the same dimension? Right? And if you look, this is 2 rows, 2 columns, so this is a 2 by 2. 2 rows, 2 columns, so this is a 2 by 2. So our dimensions check out, right? And then, so all I'm going to do is I'm going to combine the things that are in the same position. Okay? So let me show you what I mean by that, and I'll just write this bigger. So we have our first matrix. Again, we know it's a matrix because of the brackets, and they tell us. Okay. Sorry, I don't know why that's funny. All right, so this is row 1, row 2, row 1, row 2, column 1, column 2, column 1, column 2. Get used to thinking of these things using their names. It will make your life so much easier. Remember, if you can name something, then you're more likely to be able to identify it later. So, this is the first position from the first matrix. This is row 1, column 1 from this one, right? So those two things are in the exact same position in each matrix. That means that they are like terms. Again, because these are the same dimension. So that means I can add them together. Remember that we're still going to get a matrix. Don't forget, your answer is still going to be a matrix. So 2 and 7 are going to combine to make 9. Okay? Then, move to the next one. We'll take these, this 0 and this 3. 0 plus 3 makes 3. Move to the second row. Negative 7 plus 7, which makes 0. And then finally, 3 and 1 combine to make 4. I know it seems like I have just taken you through a knothole to get to there, because that is about the easiest thing we've ever done, right? But you have to really have a deeper understanding of matrices, and that's what they're trying to get you to do here. Now let's go back up there and put the right thing in the right spot, and that's where we need to pay attention to which one's the W, which one's the whatever. Okay? Now, so remember, now my writing is gone, so we'll just add these again. 2 and 7 is what went in the place where W was, right? Okay, so keep in mind what we got with our matrix. I'll just write it out. So 2 and 7 gave us 9, we had a 3, we had a 0, and we had a 4. So W is the first one they want to know, and that means what number is in that position right there. So that's 9. Then they want to know X, right? X, so that's where our 3 is. So that's 3. Y is the bottom, that's 0. And Z is that bottom right, so that's 4. Okay? So 9, 3, 0, and 4 are our answers. So you'll see that that's the only reason they're giving you these letters here in this one. What number would go in place of that letter? Don't think that your X's and Y's and Z's would be in that kind of order. Okay? How easy is that? I hope. Let's look at some more. See what else they do to us. Okay. Now, well, of course. So here they're going to give us some that are added together, and when they're added together, then they need to give us the thing at the end. But you'll notice that they've given us some variables in this one. So they've given us some unknowns. So what we're going to have to do is we're going to have to add these together and make equations out of them. Because remember, you're just taking those positions and adding them together. So let me show you. It's really not that hard. First of all, let's make sure they're the same size. This is 1, 2, 3, and by 2, right? So there are 2 rows, 1, 2, 3 columns, right? So that makes that one a 2 by 3. Here, there's row 1, row 2. There's column 1, column 2, column 3. So that makes that a 2 by 3. And you'll notice that this is also a 2 by 3. Rows, then columns. So these all are indeed the same size. that is critical, because if they weren't, you wouldn't be able to do anything. So just leave them alone. You'll see that in your homework, and you'll be very happy. Now, so what we got to do, though, is we have to see what this first one added to this second one is going to equal this third one. Well, there's our key right there. This operation symbol is between them. So just take each position. So there's an a plus 9. So it says a plus 9 plus, I'm getting that plus because these two matrices are added together. There's the thing from that position, plus 10a equals, getting that equals from right there, equals this number right there, 20. And now all you have is a simple equation that you need to solve, and that'll tell you what a is equal to, right? Because you see that we have an equation with the variable as a. So that's 1a plus 10a's makes 11a's, plus 9 equals 20. So all of algebra's equation solving, remember. Subtract the 9 from both sides, gives us 11a equals 11. Divide by 11 to get the a by itself, which gives us a equals 1. So a is 1. And then we're simply going to do the same thing over and over again for the others, right? So yeah, that means you got a lot of equations to solve. But it's just, well, not a lot of equations in this particular case, right? Now, so the next thing we'll do, let's go here. Well, it doesn't seem like that many to me, but I like them. So, so then we'll do this same thing with these. So let's do the same thing. We'll just make an equation out of it and then solve it for k. Okay. So 7z plus 1 plus, we're getting that plus from right there, 9z from the second matrix equals negative 31. And so all I have to do is then combine my like terms. So that gives me 16 z's plus 1 should equal negative 31. Get the z by itself by subtracting 1. Gives me 16z equals negative 32. Divide by 16 to get the answer of z equals negative 2. Okay? Now, there's z. So don't put it in where the k is. They solved them in a different order than I did, but it makes no difference. As long as you're getting your pieces, your component parts from the right spot, and then you put them in the right spots in there, then you're good to go. Now notice the second one, there are no values for which this statement is true. You'd get that if, say, the first one was a 2 by 3 matrix and the second one was a 2 by 2 matrix. Can't happen, right? They have to have the same dimensions in order to be able to add them together. And I'm not going to go through all of those adding them together. That's your job. So, but you're going to get a lot of practice. Whoever wrote this homework assignment loves it. All right. So, let's look at this one. Fill in the blanks to correctly complete each sentence. If the dimensions of matrix A is 5 by 3, and the dimensions of matrix B is 3 by 4, then the dimensions of A times B is. Now, so this time we're talking about multiplying matrices. So we're talking about a different animal, so let's talk about that and write out some rules for that. So let me get a blank piece of paper here. We're going to talk about how to multiply matrices. You will be so happy to know we'll never divide them. But we can multiply them. And to multiply them, it's not bad. It's really not that hard to do. It just takes some knowing. Okay? Now the first kind of multiplication doesn't really have anything to do with that problem we were just doing, but I want to show you what it looks like. And it's called what happens when you multiply by a number, which is called a scalar. Don't ask. Look it up if you want to know. I don't care. All right. So say for example we have this matrix Oops, get rid of that. Notice it has that little 5 up front. Well, anytime you have a 5 right in front of a parentheses, that always means to multiply. And when you're multiplying with anything in front of a parentheses, it means that you have to multiply that number times everything inside the parentheses. So you're simply going to distribute that 5 times every single number inside. So 5 times 2 is 10, 5 times negative 3 is negative 15, 5 times 6 is 30, 5 times 4 is 20, and remember we started with a matrix, so we end with a matrix. Okay? So that's the easiest kind of multiplication that you're going to do with the matrix. You're going to be just making sure that you multiply every single term and really watch those signs. It can get really hairy if you don't watch those signs. But we can also multiply one matrix times another matrix. And that's where we need to be very careful. To multiply matrices, so that means one matrix times another matrix. The first thing is, they don't have to be the same dimension like when you were adding. Because remember, when you're adding, you're combining like terms. But remember, when you're multiplying, you can multiply anything, right? But you have to have the same amount of information to be able to multiply. So multiplying matrices is very easy, but it's a little odd. Because what we're going to do is, okay, first of all, you're not going to be multiplying rows times rows. You're going to multiply every row from the first matrix, so from matrix 1, times every column in matrix 2. Alright? Now, so it's all of the rows and columns that you're going to be multiplying together. So if I can give you any other advice about matrices, that is, name the rows and columns. Trust me, it's going to make a huge difference in your life if you name them. And just name them row 1, column 1, whatever, using those little subscripts like I've been doing. So that's row 1, right? That's column 1. And then you'll know how all those pieces go together. Okay? Once you've done that, you're going to get a bunch of products, because that's what happens. You multiply things together, you get products. What you're going to do is you're going to add all of those products. So once you multiply them together, then you're going to add them all together. Okay? Then you're simply going to continue until you've used all the rows and columns. Now here's where you get to something that is very specific about multiplying matrices. This is the second part of it. Remember, the first part was that you were multiplying rows times columns. Well, in order to multiply rows and columns, they have to have the same number of rows and columns, because I have to have something to multiply by. Otherwise, I simply can't do it. Okay? Now again, that doesn't mean that they have to have the same dimensions. It means they have to have the same number of rows and as columns. So, in order to do this, they have to have the same number of rows, well, I can't spell now. Same number of rows and the same number of columns. Because you've got to have something to multiply everything by. Okay? And when you do that and you add them all together, you're going to get a different size matrix than you started with. So for example, if I multiply a 2 by 3 times a 3 by 2, okay? Remember, that's rows, those are columns, that's rows, those are columns. So the number of rows in the first one is 2. The number of columns in the second one is also 2. That means that yes, indeed, I can multiply them together. And then when I do that, the answer that I'm going to get is going to be a 2 by 2 matrix. Okay? The same number of rows as columns. So we're going to look at several of these and play with them so that you can see what's happening there. But it's the number of rows and the number of columns that have to match in order for this to work. Now in this particular case, the number of columns and rows here matched as well. Okay? But we'll look at examples and walk through some of these. So looking at this particular example, all they want you to see is it says what will be the size, the dimensions of this answer when you multiply it together. So we start with a 5 by 3, right? And then we have a 3 by 4. We need to see, can we indeed multiply those together? Because that's what AB means, right? That's A and that's B. Can we indeed multiply those together? And if we do, what is the size of the matrix that we're going to get as our answer? Okay, I guess it's just going to be one of those days. Rows and columns have to match, but they have to match from the two different matrices on the inside. I didn't tell you which rows and columns had to match. Okay, so if you look at this one, right, this is 5 by 3, that means there are 5 rows, 3 columns. And from this one, it's 3 by 4, that means there are 3 rows and 4 columns. The ones that have to match are these inside numbers. Okay, so it's the columns from the first matrix and the rows from the second matrix. If they don't match, then you can't multiply the two things together. Okay? Now, we can also always tell what size the answer is going to be by looking at the outside numbers here. So that's a 5, that's a 4. So once I multiply these two, well, they don't even give us a matrix here, but once I multiply those together, and then combine all those products, the answer I would get would be a 5 by 4 matrix. Okay? So columns and rows have to match, but it's these inside ones, because remember, you have 2 sets of columns, 2 sets of rows. So it's those inside ones that have to match in order for you to be able to multiply together. So in this particular instance, our number of rows and columns on the inside columns and rows match, therefore we could multiply them together, and what we would get in the end is the size matrix of the outside. So let's, So if you look at this particular problem, go back and just do a different one. This is a 1 by 2 and a 2 by 1 and a 2 by 1. So those two inside numbers match. So this answer is going to simply be a 1 by 1 matrix. The two outside numbers. Okay? Now, that has nothing at all to do with how you're going to multiply these and when you're going to multiply them, but it gives you an idea of if you get a bigger matrix than that, then you've got an issue somewhere. Okay, so let's look at, hopefully, the next question, where we're going to actually multiply a matrix. No, they don't. Okay, they want you to find the dimensions of the matrix and identify whether it is a square, column, or row matrix. Now, the square, column, and a row matrix are just special types of matrices, and they have no bearing on the mathematics. Again, this is just properties of the matrices, so you're just going to have to deal with it. But if you look at this, remember, rows are going across. So if we look here, changing gears like crazy here. That's row 1, row 2, row 3, row 4, right? So there are 4 rows, okay? That's column 1, column 2, so there are 2 columns. So this particular matrix is a 4 by 2, okay? Now, because these numbers are different, it's not going to be square. Because if you think about a square, that means they are the same. So like a 2 by 2 is a square, 3 by 3 is a square, etc. Right? The numbers are the same, and that makes a square pattern. If it's a column matrix, that means that the whole thing looks like a column. So in other words, there's one column. If it's a row matrix, there's one row, lots of columns. Okay? So you cannot imagine where that would ever make a difference, but we'll see what they do to us. Okay. So let's look at the answer to this. Remember, it has 4 rows and 2 columns. Okay, there's the size. And is it any special style? No. Okay. It looks like it's columnar because it's tall and thin, but a column would mean that it only has one column, right? So, all right. Full size of the matrix, identified as square, column, or row matrix. So the size of the matrix, it's got 2 rows, right? Well, at least you're going to be happy they're doing lots of these little easy problems that don't have much meaning. Then 1 column, right? So it's a 2 by 1. And since it has 1 column, the matrix makes a column. Okay? So you might as well have some easy homework in there too. All right. Here we go. These 2 are just equal, so they're going to tell us to multiply, then they're not going to multiply. But remember, this is just like what we did before, but instead of 3 things that we have set equal together, so we don't have any addition in there, we just have some things that are set equal to each other. So since we know they're equal, that means that the things in the corresponding places have to be equal. So this 12 and this x plus 9 have to be equal. So 12 equals x plus 9. Subtract 9 from both sides to get the x by itself. So x is 3. Now, if you could do that math in your head, just by looking up here and saying what number plus 9 would be 12, I don't need to see all of these equations written out. If you can't, then you need to set them and you need to write them out. Okay? All right, so what we'll do is we'll click on one of these so we can see all of these answers. So you're just going to set each one equal, show the completed problem, right? And notice which ones they're asking you to do, because I can do this one, like I can do this 2 and this x plus 2, and I can do this 8 and this y plus 2. I can't do the others because there's no variable to solve for, right? So there's nothing I can do with, let's just get rid of all of that. With this section, -1 equals -1. Well, duh, of course they do. There's nothing to solve there, right? So you can only work on the ones that have variables in them. So don't think you have to do all of them because there's nothing to do when you get, if there's no variable there, then there's nothing to solve for. Okay? All right. Let's see what's next. Okay, fill in the blanks. Exactly the same thing. Make sure you just take the right ones, put the right, and solve the ones that you could have variables and not. Now this one, all of them have variables, so you can solve them all. So let's just do the first one again, just to kind of show you what's going on. So the first thing is x plus 3, and that has to equal -3, right? So x plus 3 has to equal -3. It's the position of the information that lets you know that they have to be equal. So here again, we'll subtract 3 from both sides, which gets x equals -6. Make sure you put it in the right spot, because the x equals is right there. The first one they want is w. They're going to bounce those around a lot because they want you to be paying attention. They know the mathematics here is quite simple, so they want to make sure that you're closely paying attention to what's being asked. Okay? And I'll let you finish those off. Here, find the values of the variables for which the statement is true if it's possible. Okay? And if you look at this, you'll see that the values here, x, y, z, there are 3 of them. But here, when you look at this one, there are only 2. So this one has 1 row and 3 columns. The second one has 1 row and 2 columns, right? And so if you think about it, is it possible that 2 different sized matrices can be true, right? Is there an x value, a y value, and a z value given here? Absolutely not. So in this case, because these 2 things are not the same size, they can't be equal to each other. Okay? Explain to how to add 2 matrices, right? They have to be the same dimensions. They also have to have, so you're just going to add everything in the same positions, and the size of the matrix you'll get is the same size that you started with. Okay, so finding the correct value. First check the 2 matrices have the same dimension, because only matrices with the same dimension can be added. Then add the matrices. We're adding the corresponding elements or like terms. Okay? Alright, let's see. Perform the indicated operation. So this one's just an addition one. So, talked about multiplication. We haven't done it yet. So 5 and -6 make -1, etc. And then they want you to select and fill in the matrix. So the resulting matrix is, and you'll notice there's a little matrix box that comes up there, and also notice it's already the right size, right? Because there was 2 by 2, so your answer is going to be 2 by 2. Okay. All right, you're going to add these following matrices. This is a 1 by 3. This is a 3 by 1. So, well, we can't do that. Right? They're being very nice to you, although 27 questions, there's a lot of stuff. Let matrix A equal that one, B equal that one, find B minus A. Now this is the one where you have to be very careful. Now both of these are 2 by 2 matrices, right? So they can indeed be subtracted, okay? But we're just going to do one of these so you can remember what happens. So here we're going to take -3 and -2, but look, it's B minus A. So we've got to get the right number in the right order, and we have to remember that we're subtracting them. So this is B, so that's what they want to come first. So it's going to be -2 minus, because I'm subtracting here, and subtracting this first position from A, that's a -3. So that becomes -2 minus a -3 becomes +3. So I end up with +1. So watch out for order and watch out for your signs. Be very careful about what order they ask you to work these in and the signs. You should be used to that, because remember how they keep bouncing around with all the different signs. So you just do all 4 of them. Obviously I don't get 1. You'll do the whole matrix. Find the difference if possible. They're the same size, so yes. So you're just doing the first one minus the second one. So 4 minus a -5 would be a +9, right? Etc. Find the difference if possible. Finding the difference here is not possible because these two matrices are not the same size, so it's not defined. Okay? Let A equal this matrix. Find 5A. Remember, anytime you have something multiplied times that, that means that you multiply anything you have something like 5A, that always means 5 times A. So that means multiply the entire matrix by 5. So that's multiplying by a number or a scalar. So you're simply going to take everything there and multiply it by 5, right? And again, when you click on your templates, it's going to give you the matrix template to put in your answer. Okay? So we'll just show you the completed answer here really quickly. So this one says -4 times all of those. So you'll see they just took -4 times every one of those numbers. And that becomes your answer. Multiplying by scalar is really easy. Here's another one. Multiply everything by 7/2. They were very nice and gave you easy ones to work with. If you don't know how to use your calculator to multiply with by a fraction times a number by now, then you haven't listened to anything, so you're in big trouble. So make sure you understand how to make that work. Okay? But again, you'll see that because they gave the numbers they gave you, all the fractions are going to divide away. Okay. All right. Let's see. What's next? Suppose a matrix has a dimension of 3 by 1. A matrix B has a dimension of 1 by 3. Can you indeed multiply them together? Okay? So remember that in order for that to happen, so if this is a 3 by 1 and this is a 1 by 3, these two numbers have to be the same. These inside numbers have to be the same in order to multiply them together. So yes, these two things could be multiplied together. Okay? And if they can, then these two will determine how big your answer is. So your completed answer is going to end up being a 3 by 3 matrix. Okay? Haven't done any multiplication yet, but we've done something that looked like that. Remember, that's the one where I forgot to tell you it's the inside row and columns that have to be the same. I just said rows and columns. All right? So those can be multiplied, and the answer would be a 3 by 3. Matrix has a dimension of 3 by 1, and that the matrix B has a dimension of 1 by 4. They love to give you easy things here. So 3 by 1 and 1 by 4, can those be multiplied together? Well, the inside numbers are the same, so yes. And the answer you'd get when you're finished is a 3 by 4, because it's just the outside numbers. All right? And we can show the completed problem just to make sure that I'm not screwing that up still, you know. Oh, wait a minute, what did I do? 1 by 2 and 2 by 4. So with the product BA. Look at what I'm doing. Product BA. So they didn't want AB. AB can be done, but why can't BA be done? Because B is 2 by 4, A is 1 by 2, and 4 and 1 are not the same number, so they cannot be done. Make sure you pay close attention to the order. I wonder if my mistakes make your life easier or harder. Well, you're stuck with them, so we'll go with easier. All right? So these can't be multiplied together because of the order in which they were asking you to multiply. Okay. Matrix A has the dimensions, B has the dimensions, rather A and B, so they're in the right order. They both have the same 5 in the middle, yes, so 4 and 3, so they can be multiplied. So pay close attention to the order they give them to you. All right, here we go. Find the product of the following matrices if possible. Well, remember, it's got to be possible first. So the first one has 2 rows, 2 columns, so A is a 2 by 2. All right? The second one has 2 columns, 1 row, so B is a 2 by 1. Those two numbers in the middle are indeed the same. Therefore, these two things can be multiplied, and once they are, you're going to end up with a 2 by 1 matrix as your answer. So this time, we're actually going to do the multiplication. Okay? So let's look at working through this one and doing all of the multiplication. So let me get a blank piece of paper here. Hold on. So here we go. Now remember, this can get kind of tedious, but just remember what you're doing and what you're working with here, right? This is, sorry, this is row 1, this is row 2, right? And this is just column 1. We only have one column, okay? And we know that everything's going to match up because those two middle numbers were the same. Okay? So what we're going to do is we're going to take everything from row 1, okay, times everything in column 1, but there are more things in row 1. There's two things in row 1, right? And there are two things in column 1. So what's going to happen is we're going to take the things that correspond and multiply those together, and then add those products together. So let me get some space here so I can show you what I mean. Once you get this down, it's not so bad. So the first thing is a -8, right? And then the first thing in column 1 is +4. So -8 times +4. Now I'm not going to do that multiplication yet because there's another multiplication I have to do. Because also there's 0 times 4. I need to do that. So we'll do 0 times 4. Okay? So it's this one times the top one. So you're doing corresponding. And then the second one times the second one. Alright? Now, sometimes students find it easier to rewrite them so that the columns are side by side as well. Right? Be really careful if you do this. And then you can see which one's the first one, which one's the second one. You're not distributing, right? You're multiplying specific things times specific things. So if you rewrite them, be careful and remember that it's still a column even though I wrote it off sideways. And then what we can do is we can continue this math. Alright? So let's do the second one. Okay? So we've got to take everything from row 2 times everything in column 1. Just remember there's only one column to work with, so it's another row though. So we'll take -1 times the 4. So the first thing in this row times the first thing in that column. Okay? So -1 times the 4 plus, then we'll take -2 times that 4. Don't like it that they used the same number, but we'll get over it. Okay? There you are. So now that we've multiplied all those things together, let's add them up to create our matrix. Okay. So -8 times 4 is -32, plus 0 plus times 4 is 0, so that gives us -32. -1 times 4 is -4, plus -2 times 4 is -8, which gives us -12, and that is our completed matrix. Now remember, we started off with a 2 by 2, and we were multiplying that times a 2 by 1, right? So we were expecting to get a 2 by 1 matrix. Well, that's, if you look at what we got, that's 2 rows, 1 column. So that's a 2 by 1 matrix. Now you don't have to do it in the order that I did it here, showing each multiplication and then showing the combinations. You could do the multiplication and then do the combinations. I just want you to see every single step so that you can see where these things are coming from. Because if you're not multiplying the right things in the right order, this is impossible to do. As these things get bigger, they're going to get more tedious too. And be careful when you have zeros. They like to give you those zeros. Remember, 0 times anything gives you 0, but it's still one of the multiplications that you have to do. Okay? So there is your completed matrix. Alright, so let's type that in just to make sure that I didn't make any errors, because you know that it's quite possible. So we've got our matrix. So now you can choose the size of your matrix. Remember, we're going to get a 2 by 1. Oops. Need to increase it, need to decrease it. And we had negative 32. Watch your signs. And we also had down here, we had negative 12. And there we are. Okay? So it's tedious, it's weird, but it's not bad. You just have to make sure you're getting multiplying the right things times the right things. And they're going to give you several of these to work with, so you'll be very happy to know that you get lots of practice. And I'm going to work them with you, so we're going to practice together. All right, so let's multiply these two together. First of all, we need to see, can we multiply them together? So let's look at the size of the first one. The first one is 2 rows, 3 columns, so it's 2 by 3. Okay? So that's the first one. The second one is 3 rows, 1 column, so that's 3 by 1. These two numbers are the same, so yes, we can multiply them together. And luckily, we're going to get a 2 by 1 matrix when we're through, right? So let's just start our multiplications so that, remember, we're going to use row 1 first, everything from row 1 first, right? And we're going to take all 3 of those times all 3 of those. Remembering that, so to do them in order, take them in pieces, one piece by one piece, right? Make sure you're multiplying the right thing times the right thing. And again, what I'm going to do is I'm going to write it out as multiplication with addition between them so you can see every piece that I'm writing. So first I'll take the 2 times the negative 1 plus, then I'll take the negative 2 times the 4, right? So they're in corresponding positions, so it's the second one and second one. Then the third one times the third one, so 1 times 3. Right? Now, we've done those. Let's move to the second row. So it's 3 times the negative 1 plus 0 times the 4. Again, they like to use 0, but remember, 0 is a number. So 0 times, I'm sorry, that 3 times 3. And again, plus in between all of them, because remember at the end we've got to add them all together. Okay, so let's add. Oh, well, multiply then add. 2 times negative 1 is negative 2, plus 2 times negative 4 is negative 8, plus 1 times 3 is 3. Okay, and negative 2 minus 8 is negative 10, plus 3 is negative 7. Now we'll do the bottom one, the second one. 3 times negative 1 is negative 3, plus 0 times 4 is 0, plus 3 times 3 is 9. Combine all of those, which is just 9 minus 3, which is 6. And that is our answer. And it is indeed a 2 by 1 matrix. So we know the size of it is right. Let's just see if I got the numbers right. Remember, it's negative 7, 6. So get our matrix here, the right size. It's a 2 by 1. The top number was negative 7, if I'm remembering correctly. And the bottom number was positive 6. There we go. So the process isn't difficult, it's just different. It's very unlikely that you've done anything like this in the past. Okay, here we go. Find the product of the following matrices if possible. So the first thing we need to do is determine the dimensions of each one. The first one is 2 rows, 4 columns. The second one is 2 rows, 2 columns. Looking at these middle numbers, do they match? No. Therefore, we can't multiply these together. The product is not defined. Okay? So you dodged a bullet on that one. Okay? So make sure to always check the dimensions first, because that made it a lot easier than multiplying all that out and then figuring out that it's wrong. Okay? Alright. So here, that's a 3 by 1. And the second one is a 3 by 3. So, since these two middle numbers are not the same, right, we are not able to multiply these two together, so the product does not exist. Oops, what have I done? 3 by 1, 3 by 3, find the product, hold on, let me see what I've done. It would help if I would get the right thing, and remember it's always rows, then columns. That is 1 row, 3 columns. So they do indeed match. It's getting close to the end of the semester, can you tell? Alright, you probably can't because I make just as many mistakes anyway. Okay, so here we go. So we have those. The product does exist. We're going to do each one. Luckily, that's only 1 row, so we're going to have to use it times all 3 of those. And remember, we're going to get a 1 by 3 matrix at the end. So let's just do these multiplications. It's always nice for me to make sure that you do understand that I do know something about what I'm doing. So we're going to take -1 times, so we're going to take row 1 times all of column 1. So -1 times 3 plus, let me stop circling those because I can't see what I'm doing. The 4 times the next 3 plus the 2 times the 0. Alright, all I'm doing is taking all of these times all of these in order. Order is critical. Alright, so that's that part. Now, done with that one, let's use the second one. So it's -1 times -2 plus 4 times 2 plus 2 times -3. Alright, just using that second column. And now finally, we'll use the third column. -1 times 4 plus 4 times 0 plus 2 times 4. Okay. And now that's all the multiplications and combinations we need to do. So -1 times 3 is -3 plus 12 plus 0, which gives us, excuse me, which gives us 9. Okay, now we'll do this one. So that's +2 plus 8 plus 6, which gives us 16. We'll do the bottom one. So -4 plus 0 plus 8. Sorry, can't read my own writing. Which gives us 4. And that's our matrix. And we knew it was going to be a 1 by 3 because our original was 1 by 3 and 3 by 3. So we knew that it was going to be a 1 by 3 answer. So there you are. Okay? So you see that the process is not difficult. You're just going to have to practice it. And they're going to give you several of these to practice with. So I'm going to move on. Here we go. 3 by 3 times a 3 by 3. Yes, you can do that. And yes, you have to multiply all of those things out. Here, that's a 2 by 2 and a 3. But remember, it's BA. So write them in the right order. So B is a 3 by 2. A is a 2 by 2. So yes, those two things can indeed be multiplied. So be careful about the order that they want you to multiply them in. Okay, and here, part of AB, so that's a 2. So A is a 2 by 2. B is a 3 by 2. So those two can't be multiplied. Be happy about that. And finally, they want you to find the product of all of them, but since they're 2 by 2, you can find the product both ways, right? Because they're both 2 by 2, so it's easy. You're going to have to find the product of all of them. All right, and that wraps up adding and subtracting matrices. So hopefully that'll help you out through that last one. Then you're going to see that the next half of the next assignment is basically the same stuff, just a repetition. I don't know why it is, but there's nothing new on that side. And then we're going to learn how to actually use these to solve equations. And there are lots of ways to do that, and even though I was a bit of a disaster today, trust me, I can show you a very simple way of using it that will make your life easier. Okay? Until next time, have fun.